on.
All right, testing, testing.
Oh yeah, I know that's the music word.
Okay, so again, today we're going to review Chapter 3. And, I put together objectives for each lecture. So if you look at the content page on Canvas, our objectives are, we're going to review a couple of examples, right? We're going to identify and define the three fundamental measures of process flow, which are inventory, throughput, and flow time. We're going to talk about what a stable process means and how that is a fundamental assumption of what we're working on. It has to be true, or what we're doing doesn't apply. It doesn't work if it's not a stable process. Okay, and then we're going to talk about Little's Law, which is going to be key to everything that we do moving forward, right? And then I'm going to work some examples that will help show you how inventory, throughput, and flow time can apply across a broad array of environments. Okay? I'm not sure what happened there, but here we go. So one of the examples that they use is this Vancouver International Airport. And they talk about Vancouver International Airport, and if you read Chapter 3, they use it in some of the examples about how they're well known for how efficiently they get people through their airport security checkpoints, right? And so as we think about kind of what we're working on, so their focus, if they're trying to get people through this security checkpoint, is going to be how long does it take to process each person, and right, the only way that they're going to increase their throughput is to reduce the flow time that it takes for each person. And so one of the things that we're focused on in this chapter is let's make sure we understand the relationship of inventory, throughput, and flow time. Because think about Vancouver International Airport at that security checkpoint. What happens if they're slow? What happens to the lines? Okay, that's not obvious. So what happens to the lines?
Just to get longer.
Yeah, so they get longer. So here's the relationship. So what we're talking about there is the inventory in that process are the people that are in line, right? And so as flow time gets longer, our inventory increases. If we want to reduce the amount of inventory, we have to shorten our flow time. So it's just this very basic relationship that we're talking about. Okay, and then Bell South International, they were a provider of wireless services in 11 countries. This is dated, I think this text is 2013, and it's the 3rd edition, so I'm not sure what year this example came from. But they had two categories of customers. They had prepaid, which were 79% of the customers, and postpaid, which were 21%. Okay, and if you looked at the process that they had, the steps in their activation process were determination of the type of wireless service, right? They do a credit check, the selection of phone and service plan, assignment of the phone number, making a test call, and providing a short tutorial. So those are basically their 6 steps in their process, right? And they were finding that they were spending too long in terms of how long, because they weren't able to move their customers through in a timely manner. So they started to kind of look at that. Let's see. So if we're trying to manage and improve these processes, and we can use the Vancouver International Airport or the phone example, so what operational managers should a manager track as leading indicators of the financial performance of the process? And having read the goal, some of these should come, you should be able to tie these into the goal book as well, right? Because he talks about inventory, throughput, and flow time in the goal, okay? So how does the time to process a customer and the number of customers that are being served at any point in time impact the total number of customers that can be served, right? Which specific outcomes can be called improvements? And how do those process measures impact the financial performance of the process? And how can we prioritize our improvements into an executable plan? So those are things that as we go through the next 3 chapters in particular, 3, 4, and 5, we're going to look at how do we measure the process that we have, which you're going to apply to your projects, right? And then now that I've got those measurements, how do I look at that and identify based on data, based on the data that I'm collecting, how do I identify and say these are the areas of opportunity where we could make the most difference to this process? And then that narrows your focus and says, now that I've said these are the areas that can make the most difference, what is it about in those areas? What can we do? right? What's our best approach there, okay? And I always find it interesting when people were new to the continuous improvement process at Pella. I mean, we didn't talk about it in terms of inventory throughput and flow time, but we were basically focused on the same types of things, right? It's oftentimes people are focused on, they want to say, well, we need a better computer system, right? If we just had bigger, better computer system, or if I just had bigger, better equipment, okay? And so you need to not think in terms of initial process improvement should be not about capital investment, not about the big dollar investment that's going to fix everything, right? It's looking at the process that you've got and saying, okay, what are the things that we can do with the people we have and the process that we have? How can, let's make sure we have it the best that it can be before we think about doing the capital investment. Sometimes the capital investment is necessary, right? But oftentimes people think it's necessary and because the process is broken, and they haven't looked to say, okay, well, what is it that we can do to fix what we currently have? How can we make it the best it can be? Okay? All right, so in this chapter, right, there's, I think, 8 different sections. So in 3.1, we're going to define what is process flow. 3.2 to 3.4, we're going to introduce those fundamental measures. You're going to get tired of hearing me say inventory, throughput, and flow time this semester, but we're going to it's the key to what we're going to be working on. Little's Law then says how are those measures related to each other, okay? And then 3.6, I think it gets interesting because, and I'll say interesting for me because I had not really thought about applying Little's Law to financial statements until I had kind of latched onto this textbook because I was always on the manufacturing floor, so we always had visible constructs to look at. And in this case, you can look at financial statements and it's pretty interesting some of the things that you can come away with by looking at the data and using Little's Law. And so we're going to work on that. And then we'll talk about tack time and inventory turns, and we'll talk about how process flow measures are linked to financial measures of performance. And for today, we're going to hit kind of the first 3 here. So 3.1 through 3.5. Okay? So the essence of process flow. We have 3 important questions. On average, how much time does a typical flow unit spend within the process boundaries? That's flow time. So if you think about you're drawing a rectangle around your process, and if we use the HR, what are the boundaries of your process? What did we say? It was from the time that till a week after they were hired. I can remember that's the ending boundary, but what's the beginning?
Isn't it when they turned in an application?
Yeah.
Is that what we decided?
Okay.
Is that or when they accepted the job?
Yeah, when they accepted
When they accept the job. So from when they accept the job till, so you're going to take then put a box around that process, right? And then at some point in time, you're going to take a snapshot and you're going to look at how long does it take on average somebody to move through that process. That's going to be flow time, okay? On average, how many flow units pass through the process per unit of time? So when you talk about flow time, you're measuring the average of individuals that are moving through the process, right? That's where your flow time is going to come from. Your throughput is going to come from, let's look at a 6-month time period and how many people per 6 months pass through that process. That's your throughput. Okay? Your inventory is, as I look at that, as I take a snapshot, if I just go out there today, on average, how many people are there in that process today? Okay? And so basically that's your inventory, is how many applications are there. And you might say today, 3 weeks ago, 3 weeks from now, right, you're going to take some different snapshots to get a picture of how many people are in the process at any given time. Okay? The thing we'll get to with Little's Law is if you know any 2 of these measures, you can calculate the third, okay? And then a lot of times it's really easy to come up with you can almost always come up with 2 of them. The third one might be more difficult to capture, so you do the analysis using Little's Law, okay? Okay, so throughput. On average, how many flow units pass through the process per unit of time? On average, how many flow units are within the process boundaries at any point in time, okay? So there's a discussion question at the back of the chapter that says, why is it important to look at aggregate flow performance as measured by average inventory, average flow time, and average throughput? Why would you want to use averages, do you think? What happens if you don't look at averages? So what are you looking at if you're not looking at averages? You're looking at what?
Specific times.
Specific times. So if I just take specific times versus averages, what's my risk?
The specific times can change a lot easier.
Right. So maybe I'm going to get somebody who's super slow, right? So I'm going to get this picture, or maybe I'm going to get somebody who went super fast through the process. So I'm not going to get a realistic picture of what's going on. So we have to take those averages so that we can get that kind of a broad overview. In some cases, like in the university store, you are not going to want to take the average across the semester because that's not going to be realistic of where their issue and concern is, right? Their issue and concern is going to be at their peak time periods, okay? And so you can look at those averages during those peak time periods. So average is kind of, you have to define what's the best kind of perspective given the project that you're working on, okay? All right. So again, here's where they're showing, we're just drawing a box around the process, okay? And if you look, the little individual boxes that are flowing into the process, we're going to talk about that's throughput, okay? And that's how many units per hour coming into the process and exiting the process, okay? Flow time is how many hours does a unit on average spend inside the box, okay? And inventory is if I take a snapshot in time, on average, how many units are inside that process. Okay, so if I'm talking about a manufacturing line, let's talk about a bicycle production line. Okay, if I'm talking about a bicycle production line, I'm saying I process 100 bikes per hour come off this production line. That's probably, I guess I don't really know what an acceptable rate is. Let's just go with that. 100 bikes per hour, 60 bikes per hour. Okay, it's 1 bike every minute coming off the end of a production line. Okay. And then on average, there are 8 bikes inside, right, here. So my flow time, from the time it starts into here until it exits from here, right, so that's when the bike enters the process until it exits the process. That's my flow time. My inventory is on average how many bikes are actually on the production line at any given time. And my throughput is what's the rate that it's coming off of that production line. Okay, and I say off of, which is equal to into in a stable process. You're entering the process and exiting the process are going to be the same. Okay. All right. So in terms of the 3 key process measures, again, flow time, throughput, and inventory. I tend to talk about flow time, throughput, and inventory instead of flow rate, which is the same thing as throughput, because I think it's less easy for you to confuse flow time and throughput than it is to confuse flow time and flow rate. But flow rate means the same thing, how many units per hour. Okay. Flow time is the total time spent by a flow unit within the process boundaries. Okay. It's useful information to a manager who must provide a promised delivery date. Right. You're going to have to know how long it takes you to complete that process. And an indication of how long working capital in the form of inventory is tied up in the process. Okay. Flow rate, or throughput, is the number of flow units that flow through a specific point in the process per unit of time. Okay, and R sub T is a flow rate for a specific point in time. They just use that as kind of just to educate you about some of the different nomenclature that they're going to use. But the bottom line is we just typically use capital I for inventory. We use capital R for throughput, and we use capital T for flow time. Okay, inventory, throughput, and flow time. Okay. So one of the things that we want to be sure that we're aware of is understanding that inventory fluctuates over time, which is why that we take average snapshots of how much inventory is going to be in a process. Okay. We can talk about instantaneous inventory accumulation or buildup rate, which is the difference between the inflow and the outflow rate. Okay. And we're going to look at example 3.2 in our textbook. I'll just bring it up and kind of read through that. Okay, and so it's talking about this company that makes prefabricated garages. I can say that. The manufacturing facility purchased sheet metal that is formed and assembled into the finished product. Each garage needs a roof and a base, and both components are punched out of separate metal sheets prior to assembly. Production and demand data for the past 8 weeks are shown in the table at the bottom of the page, okay? And I have that on a slide, so I'll show you that here in just a second. We regard the finished goods inventory warehouse as a process and each garage as a flow unit. The production rate is when the inflow rate, while demand is the outflow rate, okay? Clearly both have fluctuated from week to week, all right? So given that, we've got I sub 0 then is the inventory at the beginning, right? And they're saying it's 2,200 garages. R sub I is the production or inflow rate for that week, which is 800 garages per week. And R sub O is the demand or outflow, okay? And if you remember in 343, we worked on some equations where we talked about how to calculate inventory. This ties right back to that, right? So inventory is, to calculate the inventory at the end of a given time period, I need to know my inventory at the beginning of that time period, what production I actually had, and then what my demand was. And so it's going to be inventory plus production. So think about it, that bicycle factory. I had 1,000 bikes at the beginning. I produced 800. Okay, that means that I have 1,800 available to draw from. And I sold 900. That means at the end of that time period, I'm going to have 900 left. Okay, so don't overcomplicate the whole inventory thing. It's very basic about what did I have, what did I produce, what minus what did I sell. Okay. All right, and so here's the table that they're showing us. And so basically, here's our ending inventory, right? So at the end of time period 0, it's 2,200, and you can see how it fluctuates, right, across time. Okay, and you can see on average then we have 2,000 units in inventory. And my average production is 1,000 units, and my average demand is 1,000 units, and therefore the change in my buildup rate is actually 0, because over time we're just balancing that out. Okay? And we kind of show that because we want to talk about, well, what do we mean by a stable process? Okay? And again, because that's an assumption when we're using Little's law, that we have a stable process. A stable process is just one in which, in the long run, the average inflow rate is the same as the average outflow rate. To say that in other words, the average inflow rate, which is what you're producing, right, if you're talking about a manufacturing plant, is the same thing as what people are buying, right? Okay. So at this point, our text makes this transition from discussing flow rate to when we have a stable process, we refer to average inflow or outflow units as throughput, okay? And so it's the average number of units that flow into or out of a process over time. So they kind of transition. Before you know you have a stable process, they talk about flow rate, right? And then after you say, yep, we've got a stable process, we transition the terminology to throughput. So when we have a stable process, we utilize the averages then of throughput, inventory, and flow time. And because of that, we can work on this relationship of Little's law, which says that inventory is equal to throughput times flow time. Okay? And then from that, I can derive that inventory turnover is equal to throughput divided by inventory, okay? Which is 1 over flow time. So here's the key things, if I were you, that I would really try to focus on when you're reading a problem or when you're thinking about your project or when you're writing up your project. You need to have consistency in your units of measure, okay? So on average, how much time does a typical flow unit spend within the process boundaries? The answer is the average flow time, which is equal to T, which your unit of measure is time. So if I say that it takes 10 minutes, right, from the time a unit enters the process until it exits the process, 10 minutes is flow time, okay? On average, how many flow units pass through the process per unit of time? The answer is throughput. Its units of measure are units per time. So if I say that I can do 60 minutes in an hour, okay, that's 60 minutes per hour, that's unit per time, I'm talking about throughput, okay? So anytime you're using a rate, it's throughput. Anytime you're just talking about specific time, there's a couple of inconsistencies in the textbook. When I write the problems for the test and whatever problems I have you work on, I'm very clear. I talk about time, I talk about units per time, and I talk about units, which is then your inventory. Okay, and so that should be your clues as you're reading the problems to be able to look at that and go, okay, well, if you're talking about units per time, you're talking about throughput. If you're talking about time, you're talking about if it's minutes, if it's an hour, whatever. If it's just time, then it's the capital T. Okay, and so then inventory is on average how many flow units are within the process boundaries at any point in time. And the answer to that is the average inventory. So Little's law says in a stable relationship, there is a fundamental relationship among inventory, throughput, and flow time. If we know 2 of the 3 measures, we can calculate the third. Okay, and oftentimes, like in a manufacturing process, right, it's pretty easy to count how many units are coming off at the end of, you know what that throughput is, right? You know how many units you have per hour. And, right, so then it's throughput, right? And then you could calculate, if you calculate flow time, right, you know from the time it starts the process until it ends the process, well, then I can calculate my average inventory, right, which would be a lot harder to count on a larger production line, right? And so you kind of pick what are the 2 that are the easiest to calculate, and you estimate the third. That's typically how we go about it, okay? All right, so let's go ahead and work an example 3.3 from the textbook, okay? And example 3.3, she says as though she can find example 3.3, is on page 56 of the textbook. And it says, recall that the average inventory for our garage place was 2,000 garages. So computing the average production over the 8 weeks charted in table 3.1 yields an average production rate of 1,000 garages per week. Average demand is also 1,000, so that means we have a stable process, right? Our inflow rate is equal to our outflow rate. Over the 8 weeks considered, therefore, average production has matched average demand. Because these rates are equal, we conclude that it is a stable process with a throughput of 1,000 garages per week. Now suppose that in terms of material and labor, okay, let me go ahead and so now suppose that in terms of material and labor, each garage costs us $3,300 to produce, okay? So I'm going to say that the cost per garage is $3,300. Right? I know that my throughput, which is equal to R, we said was 1,000. And then I always put my unit here, garages per what? Per week. Right? So do you see how that's a unit per time? So that keys me in that that's my throughput, okay? And if we consider each dollar spent as our flow unit, so now we're going to talk about dollars in terms of our flow unit, MBPF has a dollar throughput, right, is going to be equal to 3,300 times 1,000, right? And so then it becomes, instead of garages per week, now my measure is dollars per week. Okay, so we process 3.3 million, okay, per week. Thus we've evaluated the throughput using 2 different flow units. So I can transition between the number of garages to the dollars per week, okay? Similarly, we can evaluate our inventory that way, okay? If I think about what my inventory is, we said that it was on average 2,000 garages, right? Okay, and if my garages cost $3,300, I can take my 2,000 times the 3,300, right? And I know that my inventory is 6.6 million in terms of dollars. Okay, and because this is a stable process, we can apply Little's law to say the average flow time of a garage or the average time that a dollar is tied up in the system. Okay, so my flow time, right, is going to be, if I come over here, I know that inventory is equal to throughput times flow time. If I'm calculating for flow time, it's going to be inventory divided by throughput, right? I'm just doing the algebraic. So flow time in terms of garages is going to be my inventory of garages divided by my throughput of 1,000 garages per week. So basically then my time is in terms of 2 weeks, right? That's how long it takes for one unit to enter the process and exit the process. In terms of dollars, right, I'm going to take my 6.6 million, right, and I'm going to divide it by my 3.3 million, right, and it's going to come back with the same, it's 2 weeks, okay? As you get more complicated processes, you may see some changes in terms of what happens with units and what happens with dollars, because sometimes they get help. Dollars are maybe, when I say more complicated, you have different components coming in, and those components can be valued differently, and so it won't be an even Steven flow rate here. Okay, so I wanted to just kind of go over, because that's one of the first examples that they have, and the next thing that I wanted to do was go ahead and just walk through a series of examples so that you can see how these can be applied differently. Okay? Because it's pretty clear how we can apply this to manufacturing. Okay? And so if I want to do something besides manufacturing, or if I want to show you some different ways to apply it, we can talk about material flow. Okay, so I'm going to talk about material flow. It says a fast food restaurant processes an average of 5,000 kilograms of hamburger per week. So if I say 5,000 kilograms of hamburger per week, Taylor, you might wish some weeks that you don't sit in that front row, but if I say 5,000 kilograms per week, am I talking about inventory, throughput, or flow time?
The throughput?
Exactly, right? So kilograms per week equals throughput. So you can spell throughput, which is equal to R in our equation, okay? And typical inventory of raw meat in cold storage is 2,500 kilograms. If my unit of measure is just kilograms, right, it's just a unit, Rachel, what is that? Inventory, throughput, or flow time?
Inventory.
Yep, it's inventory. Okay? And if I always kind of write my equation, inventory is equal to throughput times flow time, right? And I'm saying, well, the process in this case is the restaurant, and the flow unit is a kilogram of meat. We know, therefore, that our throughput is 5,000 kilograms per week. Our inventory is 2,500 kilograms per week. And our average flow time, then, is going to be T is equal to I divided by R. So, therefore, it's going to be inventory of 2,500 kilograms divided by 5,000 kilograms per week for my throughput, right? Then that's going to tell me that on average, my flow time is a half a week, right? If I managed a restaurant, I might think that was important to know how long my food was sitting in the freezer, right? And maybe I'd have some standards that I was trying to meet to say, well, we want to improve on that. We want to get it down to a quarter of a week, especially if you're talking about your fresh vegetables and that kind of thing, right? You'd want to understand. And so again, it would be difficult to track that unit by unit to get the average flow time. But if you know the average throughput, how much you're using per week, and if you know the inventory of what you have on average, you can calculate the average flow time. Okay? All right, so let's go to another example where we're going to talk about customer flow time. Okay, this is going to be example 352 from the textbook. Okay, and it says the cafe, I'm not even going to try to pronounce it, serves an average of 60 customers per night. Okay, Courtney, 60 customers per night. Am I talking about inventory, throughput, or flow time?
Is it, would it be flow?
So Flow time is going to be measured in minutes, hours, a night, right? Okay, so if this is a rate, whenever you've got something per time, you're talking about a rate. So Zach, what are we talking about when we're talking about with a rate? Customers per night. Inventory, throughput, or flow time? Throughput. Okay. Okay. And then it goes on to say, at any point in time, there are on average 18 customers in the cafe. So Spencer, if I have 18 customers, am I talking about inventory, throughput, or flow time?
Inventory.
Right. That's our measure. That's our flow rate or flow unit. And so we're using that then in terms of when we measure our inventory, we do it in units of measure related to our flow unit. Okay. So 60 customers per night. On average, I have 18 customers. Okay. In the cafe, these customers are either enjoying their food and drinks, waiting to order, or waiting for their order to arrive. Since we would like to know how long a customer spends inside the restaurant, we were interested in the average flow time for each customer. So in this example, the process is the cafe, the flow unit is a customer. We know that we have throughput of 60 customers per night. And we know, it tells us also that our nights are 10 hours long. So if I'm trying to then convert this, I would say it's 60 customers per 10 hours. Okay. And so then if I need to know average flow time, I know that inventory is equal to throughput times flow time. So when I solve for flow time, it's inventory divided by throughput. So in this case, it's 18 customers divided by 60 customers for 10 hours, right? And so then basically that's going to convert to 18 customers divided by 6 customers per hour. And at the end of the day, divided by 6 is 3. My customers cancel each other out, and then it becomes 3 hours. Okay? So I can say on average, how long does a customer spend in the restaurant? 3 hours, right? That can be important for a lot of different reasons. If I need to I could use that information to figure out, if I had a parking lot and I knew how many people filled in my parking lot, I could use that to figure out how many parking spaces I would need. There's a lot of ways that you can use the information once you're familiar with how you can capture it. Okay? All right. So we've looked at material flow and we've looked at customer flow. Sorry, that was a little noisy. Okay, the next thing we're going to look at is job flow. Okay, and this is example 353. A branch of an insurance company processes 10,000 claims per year. Andrew, what does 10,000 claims per year represent? Inventory, throughput, or flow time?
Throughput.
Yep. Claims per year is equal to my throughput. Okay. And then it goes on to say average processing time is 3 weeks. Okay. Emily, 3 weeks represents inventory, throughput, or flow time?
Flow time.
There you go. It's going to be our flow time. Okay. We want to know how many claims are being processed at any given point. Assume that the office works 50 weeks per year. The process is a branch of the insurance company and the flow unit is a claim. We know, therefore, that the throughput, okay, so we said that they work 50 weeks per year. Okay. We were originally given it 10,000 claims per year. And then this is kind of, when you're working with these problems, remember back to your algebra. And if I need to convert, right? So if I need to convert from claims per year, right, to weeks, that's the measure of time that we're interested in. right? I know that 1 year is equal to 50 weeks. So I can cancel out my years, and then it becomes 10,000 claims per week. So I'm just adjusting my throughput to a unit of measure that makes sense. Okay, so 10,000 divided by 50 is then let me just make sure is 200 claims per week. Okay, so again, that's just getting my throughput into weeks. Okay, because we need to do that because you need, when you're doing the calculations, your throughput and your flow time need to be in the same time measure, right? I couldn't finish the calculation if my throughput was in years and my time was in weeks, right? I wouldn't get a relevant measure. So I need to make sure that I convert to either, I would need to convert into time into a year, right? So 3 divided by 52 or 3 divided by 50, given that's how many weeks they work, or I need to convert my throughput into weeks, okay? So we've converted our throughput into weeks, right? And in this example, right, we are trying to solve for, we have throughput and flow time, so we're trying to solve for inventory, which is equal to throughput times flow time. So in this case, it's 200 claims per week. And on average, it takes us 3 weeks to process. And so I can cancel out my weeks, and that leaves me with 600 claims. So again, if I worked in, what did we say, this was an insurance company? If I worked for this insurance company, it definitely would be worthwhile to understand on average how many claims do I have in the process, right? And so if I'm trying to improve my customer service, that's a measure that I'm going to try to reduce. I'm going to try to get fewer claims in the system by processing them faster, right? Okay? All right. Let's go on to the next example, which is going to be example 354, which is about cash flow. Okay? So in terms of cash flow, we know that a steel company processes $400 million of iron ore per year. Okay? So if I say 400 million per year, of iron ore, and the cost of processing is 200 million per year, and the average inventory is 100 million per year. Excuse me, it's 100 million, not per year. Because our average inventory is 100 million. We want to know how long a dollar spends in the process. So I have inventory, okay, is it Kaylin or Caitlin?
Kaylin.
Without a T, right? Okay, Kaylin. All right, so I've got my inventory is 100 million, okay? And we're saying that we want to understand how long a dollar spends in the process. So how long a dollar spends in the process, is that throughput or time?
Time.
Right. So I'm trying to understand time. So that means that what I have left then, so sometimes you can use this process of elimination, I'm trying to come up with throughput in terms of dollars per time, right? And so, but we're given 2 pieces of information, one about the iron ore and one about the processing. And so what we're going to do is we're going to combine those up to get our throughput. So what's our throughput for this process going to be?
The units per time. So
It's still going to be, throughput is going to be millions per year.
oh, so you just want to do this?
Yep.
Yeah, 6 million.
600 million
600 million per year.
per year. Right. So now I've got my inventory and throughput, and based on that, I can tell you on average how long a dollar spends in the process, right? And so flow time is equal to inventory divided by throughput. And so my inventory is 100 million. and my throughput is 600 million per year. So I cancel that out, and I do 100 million divided by 600 million is equal to 0.16667, you can keep going, of a year. Okay, but how many of us does that make a lot of practical sense to? I mean, if I talk to you about 0.167 of a year, does that really have meaning? So a lot of times we want to convert it to something that has a little bit more meaning. Okay, so maybe I'm interested in, maybe I want to talk about it in terms of months, right? So I'm going to go 0.1667 of a year, right? So then I know that 12 months is equal to 1 year. And now I can cancel out the years and I can convert it to months by multiplying 0.1667 times 12. Okay? And that's going to convert to 2 months. Something that makes a lot more practical sense for us to talk about, right? If I say 2 months, everybody has a good idea what that means. 0.167 of a year, I don't convert that easy. Okay? All right, so again, you can start to see where we've talked about in terms of the different types of flow units that we've used, right? We've talked about actual product. We've talked about actual dollars, right? And let's see, what are the other ones that we talked about? We talked about, so the type of material. We talked about customers, right? We talked about how many jobs that we're processing. So again, when I think about the HR example, we're trying to figure out, it's basically how many jobs are in there, right? It's the same thing as kind of an insurance claim approach. It's how many jobs are you working with in your process, okay? All right, and then we're going to go on and we're going to do the last example here, which is going to be example 355. I think I'll go ahead and start fresh, where we're going to talk about accounts receivable. Okay. A major manufacturer bills $300 million worth of cellular equipment per year. So they bill $300 million per year. Scotty, inventory, throughput, or flow time?
Throughput.
There we go. Okay, and the average amount in accounts receivable is $45 million. Emily?
Inventory.
There we go. So therefore, if I want to know how long a dollar spends in the accounts receivable, I can say time is equal to inventory divided by throughput, which is equal to inventory of 45 million divided by 300 million per year. Right, for my throughput, which then my millions cancel each other out, okay, and that gives me 0.15 of a year. And again, if I want to convert that into months, I'm going to say 0.15 of a year is equal to, sorry, I just want to multiply it times 12 months for 1 year, and then my years cancel each other out. And that's going to leave me with 1.8 months. So that's how long on average a dollar spends in the accounts receivable process. Okay? All right. So again, today's lecture was just about getting us comfortable with inventory, throughput, and flow time. And again, your example problems that you're going to do are just going to be based on this very similar thing. And so the key is focus in on identifying whether or not you've got inventory, throughput, or flow time in the problem. What's given to you and what are they asking for, right? So if they ask you for time, you should know in the problem they're going to give me inventory and throughput, right? If they're asking for throughput in the problem, they're going to give you inventory and time. If they're asking for inventory in the problem, they're going to give you throughput and time. Right? So it's just a matter of recognizing, here's this relationship of Little's Law, and how do I understand what these different components of information and how can I apply them to Little's Law? Okay? All right, that's all I've got for today. So I know some of you said you wanted to talk about your projects. Again, we'll spend some time next week talking about Part B, so I'll try to go over some of that with you. But again, you would probably want to start to look at Part B to understand what you're going to need to do there as well. Okay? Any questions for me before we call it a day? All right. Oh, and I need your attendance for today.